Hello guys, welcome to the channel, and in this video we're going to be predicting house prices by using machine learning, so linear regression basically. To begin with, we're going to import the two required libraries, which are pandas and numpy. Next, we're going to get some data into a pandas data frame and store it in a variable called house_data. So this is the Kaggle dataset which I'm using. I'll be attaching a link to this dataset in the description box below. So what you'll basically need to do is download this dataset on your local machine and you'll be good to go. So I'm reading the CSV file into a variable called house data. And as you can see in the dataset, we have a price column, an area column, it has location, number of bedrooms, if it's a resale house or not, and so on. So if we take a look at the dimensions of our data set, there are about 6,200 rows, that means there's about 6,200 houses, and 40 columns, that means 39 features of the house and one price column. Moving forward, we're gonna get a correlation matrix just to see how the price correlates with other features of the house. So obviously, if we think logically, the more the area, the higher the price. The more the number of bedrooms, higher the price. If it's a resale house, the price is going to go down, so it has negative correlation. And as you can see, these three features have the highest correlation with the price, and the rest of the features, they're not so correlated. Also, this is an important criteria, I feel, so we're going to be including that. Getting a list of columns. So now what we're doing is basically we're just printing out whatever our columns are, just for us to be able to select what columns we're going to be choosing for our feature selection basically. So as I said, looking at the correlation matrix, we'll be selecting these 5 features, which is area, number of bedrooms, if it's a resale house or not, if there's an elevator available, and if there's a nearby sports facility. So we're going to be selecting these features as our x. So when choosing x and y variables, we're going to choose x, which always stores independent variables, or the features, and y stores the dependent variable, that is the value to be predicted. So in this case, we're going to be predicting the price of the house, so the price column goes into our y. And what I've done in this line of code is basically I've just renamed number of bedrooms in a different way, just to make it easier for us to write. And also what I'm doing here is I'm just scaling the y values a little bit because the original values are way too large, and when we scale these values, it becomes easier for the machine also to it works faster basically. So that's why we're scaling the values. It becomes easier to handle data. So when we print x, as you can see, we have a completely new data frame, which has only the area, the number of bedrooms, if it's a resale house or not, if there's an elevator available, and if there's a sports facility. And when we print y, we get only the price, which, as you can see, the numbers are scaled properly into workable numbers. Now, to work on our model, we're going to import train test split function from scikit-learn library. So from scikit-learn.model selection, we're going to import train test split. What we're basically doing here is we're dividing our x and y into training and testing data sets. So as you can see, these are the 4 variables that we're going to be dividing the data set into. So xtrain is going to be some values from the x data set used for training. Then the remaining values are going to be testing. Similarly, for y, some of the values are going to be trained and some of the values are going to go into the testing data set. And we've specified x and y. So what we x and y is basically these. We'll be using these to, we'll be working with these for our model. And I've specified the training size as 0.7. That just means that out of the 6,200 rows, the 70% of these rows will be going to the training data sets, which is the X and Y train, X train and Y train. And the remaining 0.3% will be going, 30% will be going to the testing data set, which is the X test and the Y test. And if we print the shapes or the dimensions of these data sets, we get that 4344, which is approximately 70% of 6,200. So our training data set is properly divided. So X train and Y train is going to be 4,300 columns, 4,300 rows, sorry. And Y train has our price column, and X train has our 5 features over here. Similarly, X test and Y test. That will have the remaining 30%, which is around 1,863 rows. So after splitting our data, we're going to build a model. Now this might look like 3 lines, but it has a lot going on in the background. So we're importing linear regression from scikit-learn again. So scikit-learn.linear-model, import linear regression. And this is just the name of our model, which is our linear regression model basically. And we're fitting the model using X-train and Y-train. So what this .fit function does is that it trains the model based on these X-train and Y-train values. So if you can remember, X-train has all the features of the house from the training data set, and Y-train has the price column from the training data set. Now, since we've trained the model using fit, now we can go and predict the values of X test. So what this line of code is doing is that we're telling Python to predict the values of X test by using the model that we just built, which is REGR, and store the values in Y-test-pred. So whatever the model predicted, whatever values the model predicts for X test will be stored in a variable called Y-test-pred. So just to get a visualization of how those values are predicted, we're going to plot the original values from the data set, which is Y-test, and predicted values from the model, which is Y-test-pred. So as you can see, we're first doing a scatter plot of Y-test. Next, we'll be doing a scatter plot of Y-test-pred. So our original values are the test data, which is the black dots that you see, and the stars are the predicted data, or the predicted values. So if this doesn't provide a good way to visualize, we can also do this. We can put the 2 columns side by side and then see how accurate our model is. So we're just printing the first 50 values of the predicted prices. So this price column is basically our Y-test column, which is basically the original prices in the data set. And the predicted price column is the Y-test-pred column. So basically the prices that the model that we built predicted. So as you can see, the first value is almost matching, so 58 and 58. Original price was 58, predicted price 58, so yeah. The next 3, I guess, they have a lot of difference between them. So we can go on comparing the values. Comparing left with the first column with the second column. And then we can take a completely new value for X, which is our features of the house, and predict the price of the house based on X, based on our model, we can say. So what we're basically doing is, again, like we did above, REGR, which is the name of our model, .predict, so what we want to predict. So let's say the area of the house is 1,200 The number of bedrooms is 3, and there is no elevator. It's not a resale house, and there is no sports facility. So what would be the price of this type of a house? That's what we're predicting, and we're storing the value in YNewPred. So when we print YNewPred, we get 69.16, which is the price of a house which has these features. So congratulations, there you go. We just built a model to predict house prices using linear regression. But this was a really basic video just to give you an introduction of what goes on. And thank you for watching, and do subscribe to the channel. Thanks.